Hello students, in the previous group I started the logic group instructions. So the next instruction that I'll be discussing in under logic group instructions are XOR instructions. So I'll be discussing first the XOR instructions, then we'll move ahead with the next logic group. So here in this slide I've shown all the XOR instructions, those instructions that perform XOR operation, that is XOR. Now under XOR operation, the first instruction is XOR. So what does this instruction do? It performs the XOR operation between the mentioned register and the contents of the accumulator and stores the result, that is stores the XOR operation result in the accumulator. So whatever register you can mention, as I've told you, there are B, C, D, E, H, L registers present in the 8085 microprocessor. Any register you can mention, and what microprocessor will do, it will perform XOR operation between the contents of accumulator and the content of the register mentioned. Either it can be B, it can be C, or D, or E, or H, L. Any register of 8085 microprocessor between these two contents, and the result will get stored in the accumulator. Now flags affected. Now here again there is a setting. 8085 microprocessor has been manufactured in such a way that whenever XOR operation is going to get performed in this 8085 microprocessor, then all flags will get affected, but the status of carry and auxiliary flag will be 00, which shows that the operation that is being performed by the microprocessor is XOR operation. Again I am repeating, in whenever a microprocessor 8085 microprocessor is performing XOR operation, then all flags will get affected except auxiliary carry flag, and their status will remain 00 only. Number of bytes, obviously there is no hexadecimal number mentioned along with this instruction, so number of byte will be 1, which is for the opcode. Machine cycle, only one machine cycle will be used. How? That is, one machine cycle, first machine cycle will be used for opcode fetch. After fetching the opcode, microprocessor will get to know that it has to perform XOR operation between accumulator and the mentioned register. Both the accumulator and mentioned register are present in the microprocessor, so it does not have to perform any extra machine cycle either to memory read or memory write. So only one machine cycle is enough for complete execution of this instruction. T states, number of T states will be 4, as opcode fetch machine cycle here will need only 4 T states. Addressing mode for this operation, as you can see, both the operands are content of the register. So the addressing mode will be register addressing mode. Now next instruction of XOR operation is XRAM. XRAM, it performs the XOR operation between the accumulator and the memory location and the content of the memory location, and stores the result in the accumulator. So what is memory location? Memory location, its address is pointed out by HL pair. So whatever is the content of the HL pair, that will be the memory address, and the content of memory location, and content of memory location will get into this XOR operation with the content of the accumulator, and the result will get stored in the accumulator. Again, since it is a XOR operation, so all flags will get affected, and the status of carry flag and auxiliary carry flag will be 00. Number of bytes, obviously there is no hexadecimal number mentioned along with this instruction, so number of bytes will be 1. Now machine cycle, how many machine cycles? Okay, first machine cycle will be used for opcode fetch. After fetching the opcode, microprocessor will get to know it has to perform the XOR operation with the content of the, it has to perform XOR operation between the content of accumulator and the content of memory location whose address is pointed out by HL pair. So microprocessor is having the address, but it has to read the content of that address. So second machine cycle will be used for reading the content of memory location pointed out by HL pair. Once the content reaches the microprocessor, XOR operation will be performed and the instruction will get executed and the result will get stored in the accumulator. So only 2 machine cycles are enough to fully execute this instruction. Here I've written also 2 machine cycles. T states, obviously opcode fetch here will need 4 T states and memory read will need 3 T states. So all total 7 T states. Addressing mode is registered indirect. Why? Because here the operand is the content of memory location whose address is indirectly pointed out by HL pair. So here the addressing mode is registered indirect. The next XOR operation is XRI 8-bit data. So what XRI 8-bit data does, it performs the XOR operation between the content of the accumulator and the content immediate immediate data that is mentioned in the instruction. So whatever immediate data, 8-bit data is mentioned in the instruction, that data and the content of accumulator, XOR operation will get performed between these 2 contents and the result will get stored in the accumulator. Flags affected, again all flags will get affected except carry flag and auxiliary carry flag. The status here will be 0 only. Number of bytes of the instruction, as you can see, this XRI 8-bit data contains one hexadecimal number, one 8-bit this hexadecimal number mentioned along with this instruction. So the number of bytes, 1 will be for opcode and 1 byte will be for the 8-bit data mentioned in the instruction. So overall 2 bytes for this instruction. Machine cycle, obviously it will need 2 machine cycles. First machine cycle for opcode fetch. After fetching the opcode, microprocessor will get to know that it has to perform the XOR operation between the content of the accumulator and the 8-bit data. So the second machine cycle will be used for reading this 8-bit data mentioned in the instruction from the memory. So second machine cycle will be memory read, and within second machine cycle the XOR operation will get performed also and the result will get stored in the accumulator. So overall 2 machine cycles are needed for complete execution of this instruction. And T states, opcode fetch obviously need 4 T states and memory read needs 3 T states. So overall 7 T states. Addressing mode, immediate addressing mode, as the operand is directly mentioned in the instruction, so the addressing mode will be immediate addressing mode. The next instruction that I'll be discussing under logic group are those that are related to OR operation. So we have 3 instructions which perform OR operation: ORAR, ORAM and ORI 8-bit data. So ORAR, what it does, it performs the OR operation between the content of accumulator and the register. Whatever register is mentioned, for example ORAB, it can be any register of 8085 microprocessor. So it performs the OR operation between accumulator and the mentioned register and the result gets stored in the accumulator. Now flags affected, again here all flags will get affected, but the status of carry flag and auxiliary carry flag will be 00 only, because the microprocessor has been manufactured in such a way that whenever OR instruction will get performed in this microprocessor, the carry flag and auxiliary carry flag will show the status 00. Number of bytes, obviously there is no extra hexadecimal number mentioned along with this instruction, so number of bytes will be 1. Machine cycle, only 1 machine cycle, and that too for opcode fetch, because after fetching the opcode, microprocessor will get to know it has to perform OR operation between contents of accumulator and the mentioned register. Both accumulator and mentioned register are within the microprocessor, so it does not have to perform extra memory read or memory write machine cycles. So only 1 machine cycle is enough for complete execution of this instruction. T states, 4 T states, because here only one machine cycle, that is opcode fetch machine cycle, is used, and it needs 4 T states. Addressing mode, the addressing mode will be register addressing mode, because here the operands are both the contents of the register. So the next instruction is ORAM. What does ORAM does? ORAM is, it logically ORs the content of memory location pointed out by HL pair with the content of accumulator, and the result gets stored in the accumulator. So again, what this AM represents, AM is the address which is given by the HL pair, and the content of AM, content of this memory location, and the content of accumulator, the OR operation will get performed between these two, and the result will get stored in the accumulator. Flags affected, obviously all flags will get affected except auxiliary carry flag and carry flag. Their status will be 0 0. Number of bytes will be 1 byte instruction, because no hexadecimal number mentioned along with this instruction. Machine cycle, it will need 2 machine cycles. Why? Because first machine cycle will be used for opcode fetch. Sorry. Okay, first machine cycle will be used for opcode fetch, and after fetching the opcode, microprocessor will get to know that it has to perform OR operation between the content of accumulator and the content of memory location. So here the content of memory location, microprocessor needs another extra machine cycle to perform this to read operation, to read the content of the memory location. So one for opcode fetch and one for memory read. Number of T states, opcode fetch will need 3 T states, memory read will need opcode fetch will need 4 T states, memory read will need 3 T states, so overall 7 T states. Addressing mode, obviously it is register indirect addressing mode, because here the operand is the content of memory location, which is indirectly specified by HL pair. So the address, so here what is happening, the address of operand is indirectly specified by HL pair, so here the addressing mode will be register indirect. Now next instruction is ORI 8-bit data. ORI 8-bit data, it performs logical OR operation between the content of accumulator and the 8-bit data mentioned in the instruction. Yes, the 8-bit data mentioned in the instruction, and the result will get stored in the accumulator. Flags, all flags will get affected, but the status of carry flag and auxiliary carry flag will remain 0 0. Number of bytes will be 2, because one byte will be for opcode fetch, and the second byte will be for the 8-bit data mentioned in the instruction. So overall bytes for this instruction is 2 bytes. Now machine cycle, it will need 2 machine cycles. First machine cycle for opcode fetch, and after fetching the opcode, microprocessor will get to know it has to perform OR operation between the accumulator and the 8-bit data. So the second machine cycle will be used for reading this 8-bit data from the memory. So second machine cycle for memory read, and within second machine cycle, after the content reaches the microprocessor, the instruction will get executed. T states, 7 T states, because opcode fetch will need 4 T states and memory read will need 3 T states, so overall 7 T states. Addressing mode, because here the operand is directly mentioned in the instruction, so addressing mode will be immediate addressing mode. I am ending this class here. We'll continue with the logic group instructions in my next lecture also. Thank you.